We are continuing with our embryology session. So if you haven't watched the previous video, watch it in the link above. I've come up with a very easy mnemonic for primordial germ cells, oogenesis and spermatogenesis. So watch the whole video and take your notes. I've put great effort in the video and I hope I can explain it well. Try to support me by subscribing to my channel. Now for primordial germ cells, we have the gametes produced from the primordial germ cells. Gametes have been explained in the previous video. They are sperm for male and ovum in female. So primordial germ cells are weak. So all the production to migration of the primordial germ cells are in weak. So first we split the primordial germ and cells into three components. First we have primordial. So for the first word we have di in the name and it is produced in the second week from the epiblast and migrate to yolk cell. The second word is germ. So in the fourth week they start migrating towards the gonads. And the last word is cells, and in the fifth week they reach gonads where they undergo gametogenesis, which leads to gamete formation, which is sperm and ovum. And for epiblast, for now you should remember it is the outer layer of the embryonic disc. Next is oogenesis. So for the overview and the techniques, you should remember that two things are happening in oogenesis. First is the follicle development from the granulosa cell, which are the outer cells. Next is the primordial germ cells to ovum development, which is in the inside. Next, for oogenesis, we split the initials of primordial germ cells, the P, G, and C. For the P in oogenesis, we have primordial germ cells itself. For the G, we have oogonium that undergoes mitosis. Next, for the C, we have oocyte that undergoes meiosis and stops in primary meiosis or meiosis 1 in prophase 1. So we have primary oocyte. So for the P, we have primary meiosis, that is meiosis 1, and for the P, we again have prophase 1. Next, in the follicular development, which is going parallel, we have P again, and for the P, we have three words. First is the primordial, that is the longest word. Then we have primary follicle, that is the middle word. Then we have the pre-follicle, that is pre-antral follicle, which leads to formation of secondary follicle. Then from secondary follicle, we have the Graafian follicle, which has G in the name. So we have Graafian follicle, which has a C, that is secondary oocyte. So for secondary, we have second meiosis and we take the second word initial and we have M, so we have metaphase 2. Then we have ovulation and then the formation of corpus luteum. Next, there are ovarian cycle phases. Ovarian cycle phases are related to follicle. First, we have follicular phase, then we have luteal phase. We will overview this and we will discuss in detail in next chapter. Next, the overview of ovarian cycle is we have the word follicle. So we can write the word follicle like this, F, O, L, and L. So for the F, we have follicular phase. For O and L, we have ovulation and LH surge. For the L last, we have luteal phase. So in follicular phase, we have the word F. So it is under the effect of FSH and it is 14 days, which can vary. Next is O, ovulation, and L, that is LH surge. Next is L, luteal, and it is 14 days, that is fixed. You should remember these are important for MCQs. Next we have G and RH hormones that are FSH and LH, which will be discussed later. Next we have one cell that is important, that is granulosa cell, which is for everything, and here are granulosa cells. So granulosa cells leads to formation of cumulosophorus, theca, and zona pellucidea, which we will discuss in a moment. Next, again, as we had discussed earlier, we have first primordial germ cells from the P, then we have G, oogonia, then we have C, oocytes. So first from primordial germ cells, we have formation of oogonium from G, and oogonium, that is diploid 2N, undergoes mitosis again and again and produce more oogonium. And in the third month, some of oogonium form primary oocyte that is arrested in prophase 1, as we discussed earlier. This is also diploid and it is arrested under the effect of ovarian maturation inhibitor substance. The important thing is that oogonium keeps on increasing, and in the fifth month there are 7 billion, then they become atretic or die. Next, the parallel development of the follicle, we have primordial follicle. So in puberty, primordial follicle converts to primary follicle, and the primary oocyte comes out of the stage of prophase 1, and there are 4 lakh in puberty and only 500 of them are ovulated. So it undergoes the process of meiosis one and it forms secondary oocyte, and secondary oocyte is present in mature follicle or Graafian follicle, which we discussed earlier. Then we discussed that the secondary oocyte is arrested in metaphase 2 for the 3 hours, and then there is LH surge which leads to ovulation, and the secondary oocytes complete the process of
meiosis 2.
which forms the ovum, and if it is fertilized it forms the zygote, and with this we have formation of corpus luteum with it. Now here we discuss in detail what is happening in the development of follicles. So first we have primordial follicle, that is flat epithelium. Then we have primary follicle, that is cuboid epithelium. Then we have secondary follicle that has stratified cuboid epithelium. Then we have tertiary follicle that has spaces between them. Then we have pre-ovulatory follicle that is ready for ovulation. Here in the follicle we discuss the theca cells first, and in the theca cells we have outer theca cells that have blood vessels, so we have mnemonic bout, and for the inner cells that secrete steroid we have mnemonic ins. Then we have granulosa cell around the oocyte, that is cumulus oophorus. Then the glycoprotein layer secreted by granulosa cell and oocyte is the zone around the oocyte. Here is the glycoprotein layer, and around this is cumulus oophorus. All the number of follicles that start one only reaches the maturity. Next is formation of sperm, and in formation of sperm we have two phases. First is spermatogenesis, then is spermiogenesis. In spermatogenesis we have the first initial A, and the spermiogenesis we have I, which comes in letter alphabets after the A. So in spermatogenesis the spermatogonia forms spermatids. Here we have I, which is in spelling sequence earlier than the word O. In the spermiogenesis, we have spermatids converted to spermatozoa, and ozoa has last words O, Z, O, A, which is like ovum. So remember that spermatozoa is the last product of the spermiogenesis, whereas in spermatogenesis, we have last product spermatids. So remember the spelling sequence that the spermatids I comes before the O. Next again we have the PGC mnemonic. For the P we have primordial germ cells, for the G we have spermatogonia, and for the C we have spermatocyte. So spermatogenesis is related to two hormones. First is FSH, and FSH has S in the name. It acts on the Sertoli cells and it leads to spermatogenesis, and AIM hormone, that is androgen binding protein, inhibin and Mullerian inhibiting substance. For LH we have Leydig cells and it releases the testosterone and T looks like L. Next is spermatogenesis, spermatogonia to spermatids formation. And next we have supporting cells, that is Sertoli cells and testicular cells. So first we have primordial germ cells.
Which forms spermatogonia.
Before puberty, sex cord acquired lumens. Here we have Sertoli cells. Here we have outside or interstitial cells that are Leydig cells. Here we have spermatogonium. So first PGC converts to spermatogonia, that is spermatogonia A and spermatogonia B. So spermatogonia A undergoes mitosis and in the last division it gives spermatogonia type B. So spermatogonia type B divides and enter meiosis 1, and in this we have primary spermatocytes in prophase that is arrested for 22 days. Then it leads to formation of haploid spermatids. Spermatogonia and spermatocyte derive their nutrition from the Sertoli cells, and all of this is under the effect of LH and FSH hormone. Next, here we have type A spermatogonia that forms type B spermatogonia, which forms primary spermatocyte that is arrested in prophase 1 that leads to formation of secondary spermatocytes, which form spermatids. Now in spermiogenesis, the spermatids are converted to spermatoozoa, spermatoovum. You can remember like this, or the E comes before O. So we have four steps: AC, MS. For AC we have air conditioner. For MS we have here the mist shouting. For A we have acrosome, that is enzyme to penetrate the egg, which we will discuss later. Then for C we have condensation of nucleus. For M we have formation of neck, middle piece and tail. And for S we have shedding of cytoplasm. Here you can see that this is spermatid and this is spermatozoa with the head, mid piece and tail. Here is the formation of acrosome. Here is the condensation of nucleus. Here is the shedding of excessive cytoplasm and the formation of middle piece, neck and tail.